Hello, folks. So this first lesson is one that doesn't come from the textbook and is a little more low stakes and is on the everyday reasons that statistics are important. And so we know from educational theories and evidence on how people learn that we can't learn new knowledge or new information until we can link it to our existing knowledge base. So you can't learn something new about statistics unless you can link it to what you already know about statistics. And so this lesson really helps you think about all of the knowledge you already have about statistics, even if you didn't know that that was statistics knowledge that you have. You might not have even realized it. So I want to go through a number of examples of things that are statistics from everyday life that you already are familiar with. And so this is, one to kind of help you connect some of the things that we'll be learning about statistics to things that you already know. But this is also my strategy to show you here's why this course really matters, right? It's not just that if you want to become a criminologist or a sociologist who uses statistics for research, but here's in your everyday lives how statistics come into play. And the first example I have here are for weather forecasts. So meteorologists use statistical models to predict future weather occurrences using data on past weather situations. So they might be looking, for example, at predicting hurricanes, and that's what this little model in the picture here is for. And in predicting hurricanes, as an example, models take data on past hurricanes, including things like ocean or air temperatures, the wind speed, the size of the storm, and using all of these pieces of information from past events, they're able to make a statistical prediction about where the storm will go, how strong it will be, the intensity of it, etc. So they take all of this information about how a hurricane progressed in the past and apply that to a future prediction. And so they might use what are called these spaghetti plots in this picture here that shows the different models or predictions of where the hurricane might go. We know that there's also all kinds of what we'll learn are called descriptive statistics in weather forecasting. So it's not just about making predictions of future weather events, but also about current weather conditions include all types of variables. This can be things like what's the average rainfall to date so far this year. That's a statistic. What is the average temperature on any given day of the year? That's a statistic. So lots of ways that weather forecasts, when you check the weather on the app on your phone, this is all statistics. Another example is predicting disease. So we can think about for predicting disease both what are considered prevalence rates, so how common a given disease is, as well as associations, statistical associations. And a statistical association is more about if you have a particular characteristic or lifestyle or condition, how does that influence the likelihood of you getting a disease? So in terms of prevalence rates, this is really about knowing what percentage or number of people have a certain disease. So for example, we could say, what are the percentage of Americans who have experienced COVID-19 to date? How many Americans have died of COVID-19 as of this point in time? That would be a statistic, that's a prevalence. We also know then the associations are what factors are associated with getting that disease. So for example, 85 to 95% of lung cancer is related to smoking, right? So knowing that if you're a smoker, your risk of lung cancer is higher. That's a statistical association. We could also look at kind of prevalence rates by different demographic characteristics. So continuing with the COVID-19 example, that's obviously very timely right now, that we know mortality rates among Black and Brown Americans are about 3 times higher than they are for whites. That's very much a statistical prevalence rate. Okay, so predicting disease, another big example in your everyday life. Medical studies as well. So you take a drug when you get a headache. How do you know that that drug is supposed to help your headache? They've conducted a medical study to determine that, right? So that's an example of a pharmaceutical medical study. That these studies must show us what's considered, and we'll learn a lot about this in coming months, a statistically significant difference between a control group and a treatment group, right? That one group is randomly assigned to get the treatment or the new drug, and the other group is totally like the treatment group in every way, same age, same races, same genders, the same other pre-existing health conditions, but they don't get the treatment or the drug. What's the difference between this control group and what's the difference between with this treatment group? And if there's a difference, is that difference big enough for it to not just be by luck, but we conclude that that treatment or medicine actually works? Statistics is really critical in doing that. Political campaigns are another example, and a very timely example, of course, for the use of statistics, right? So one way that's in terms of just being a descriptive statistic, what percentage of the electorate voted for a given candidate, right? We also use statistics in political predictions of trying to poll likely voters and figure out which candidate is likely to win, right? It's obvious that we can't poll every single voter. So polling models look at how many, for example, women do we need to poll to feel confident that we can guess how many women are going to vote for a given candidate? Do we need to poll what percentage of the racial breakdown to make sure that our sample is representative of all likely voters? And so we hear a lot about, the polls were wrong in certain examples of political races. And of course, the recent 2016 presidential election is one great example of this, in which we heard a lot that the polling predictions were wrong, right? That the polls predicted that Clinton would win when, in fact, of course, Trump won. And so this graphic I have here is illustrative of how it's not that the polls were wrong, it's that people misunderstand the accuracy of the polls, right? So most political polling has what's called a 3% margin of error, and we'll talk a lot more in coming months about what this 3% represents and what a margin of error means. But this essentially means that whatever guess they have for the percent of the electorate that's going to vote for a given candidate, they're acknowledging that this could be 3 points off, that this could be 3 percentage points too low or 3 percentage points too high. So when the polling predictions were, and there were, of course, a ton of these and all over the place, I just picked one of the most commonly cited ones to illustrate this point here and show how statistics matters in your everyday life. One of the most widely cited polls right before the election predicted that Trump would get 44% of the popular vote and Clinton would get 47% of the popular vote. But this poll had what's considered a 3% margin of error, meaning that 44% could really be 3 points lower than that, 41%, or 3 points higher than that at 47%. And so then when we look at what the actual percent of the electorate voting for each candidate was, we see that the actual rates were within this 3% margin of error, right? That Trump had 46% of the popular vote and Clinton had 48%. Both of these, this is not that the polls were wrong, that they were both within this 3% margin of error. So obviously with the next presidential election coming up in several months, we'll see a lot more of this. And just a quick reminder to register to vote if you have not already. Sign up to get a mail-in ballot. All of the info for that is on the end of our syllabus as well. Okay, like how I snuck that in there, right? Okay, consumer goods is another example. So let's say you manage a large big box store or a small retail establishment. How do you know when to buy or stock up on certain items as a manager? This is statistics all over. So how do you know when to ship new items? You're looking at trends given past events. And so some of these are obvious, right? So a retail store is going to order more shorts and summer clothing before summer months start. A grocery store is going to order more bread and milk if there's the prediction of a big snowstorm coming. Some of these, though, are always really interesting. For one kind of crazy example is Walmart learned that Pop-Tart sales dramatically increased before a hurricane. So they know they need to stock up on Pop-Tarts if there's a hurricane approaching, if they want to maximize their profit. So consumer goods is an interesting one as well. Another example is for insurance, whether this is for auto insurance, homeowners insurance, life insurance. Insurance companies need to determine how much of a risk or liability you are. So as a driver, for example, given everything they know about you as an individual and your life circumstances, how likely are you to get in a car accident and cost the insurance company money? That's how your insurance rates are determined. And I have a couple of examples here of factors, or what we'll learn are called variables, that might influence your car insurance rates, right? So age is a big one. People who are older drive more conservatively and safely. Younger people are more reckless and impulsive and thus more likely to get into an accident. So your insurance rates are higher. Gender matters. Males are more likely to be impulsive and drive fast than women. Marital status. If you're married, this is supposed to be an indicator of stability, that you have somebody else in your life that you are invested in and are going to be less reckless because of that. Neighborhood is another big one. Think about, would you expect, for people who are familiar with different neighborhoods within Philadelphia, car insurance rates to be higher in a place like Manayunk that is very difficult to drive in? Streets are congested, lots of big hills up and down, limited parking spaces. A place like Manayunk or a place like, I don't know, Chestnut Hill, that's a little more spread out, is less densely populated. Obviously, then, if the risk of accident is less in Chestnut Hill, or a risk of a fender bender or bumping into another car while parking is less there, then your auto insurance rates are going to be less if you live there as well. So that's why car insurance places ask for your address so they can figure that out. Some even ask also for the address of your employment so they can figure out how far you have to travel between work and home. If you have a farther commute, that's a higher chance of an opportunity to get into an accident. Type of car matters. Red cars have higher car insurance rates. The assumption is that if you're driving a red car, it's something sporty and fun and flashy, so you're going to be more likely to be speeding and driving recklessly. And then, of course, your past driving record. This is known as anamnestic prediction, the idea that past behavior influences or predicts future behavior. If you got in accidents in the past, we think you're likely to get in accidents in the future, so we're going to charge you higher car insurance. But so for anyone who has ever needed to purchase insurance, these are some of the ways that statistics have been used to influence your car insurance. Sports. So if I'm struggling to think of if there's anybody who hasn't connected to one of these so far, right? Somebody who's never checked the weather, never had to get car insurance, never bought anything from a store. But if so, then the one that I would expect maybe that you have definitely have a connection to is sports. Tons of what are considered descriptive statistics in sports. So how do we use a number to summarize somebody's athletic performance? For example, a batting average. What is an individual player's batting average for a given season? How does that compare to last season? How does that compare to other players? Those are all statistics. Free throw percentages is another example. This is where gambling comes into play, that there is big money in figuring out how to predict what team or what player is going to win based off of a variety of variables, right? Under what conditions does a player perform best? If they're at home or away, if they are playing a team with a given record. These are really advanced statistical models that really high-paid statisticians are able to use to make gambling predictions. We'll have a couple of circumstances this year that if you are into sports gambling, which I am not, even the statistician in me days away. As much of a sports fan as I am, I think it's a waste of money. But if you are a sports gambler, we'll have a couple of circumstances this semester in which you might get a tip or trick in terms of thinking about how sports gambling works. Okay, and then the last example I have, so I've gone through all of these examples about how statistics matter in your everyday life, and since this is a sociology course, I will conclude with just a couple of examples of how statistics influence some of the sociological phenomenon that you may have studied in other classes so far. So I have a couple of research questions here that we know studies have used statistics to answer. So one research question is, are students who attend schools with more financial resources less likely to commit crime in the future? And we've had numerous statistical studies that confirm that the answer to this research question is yes, that students with more financially supported schools are less likely to commit crime in the future. The second one here is a drug offender more likely to commit crime after prison compared to if they received drug treatment or not? Sorry, the wording of that question is a little funny. I don't know what's up with that. But the idea is somebody who goes to prison versus gets drug treatment, who's more likely to commit crime in the future? And the answer is that somebody who goes to treatment is less likely to commit crime compared to somebody who just goes to prison. The last question here then is, are school administrators more likely to suspend darker-skinned students than lighter-skinned students? So this taps into some of the racial phenomenon maybe you've learned if you've had a class with Dr. Gallagher yet on colorism. And the answer to this is actually a couple of researchers nearby at Villanova have done some large-scale national studies and found that even with a school administrator who is of color, who is a Black and brown person themselves, darker-skinned students are more likely to get harsh punishment than lighter-skinned students, all else being equal, right? So for the same type of school infraction or offense. And so here's just some of the ways in which not only statistics influences your everyday life, or may have been in examples of things that you encounter in your everyday life that you might not have even realized, but also some examples of how statistics matters for some of the sociological phenomena that you may have studied in other classes so far. Okay, so I hope that these were helpful examples that started to get you excited about the semester and why learning statistics will be, I promise, actually fun and exciting and not as scary as many of you expect it to be. So stay tuned for our next lesson next week on Chapter 1 in the textbook. And make sure, if you have not yet done the class survey online, do that. This gives us some really fun data to be able to play around with this semester if you go ahead and take a couple minutes to do that. Okay, take care, guys. I'll talk to you soon.